Hello everyone, welcome to session number 3. In the previous section, we have taken a look at the L2 VNI configuration where we established the connectivity between the clients in the same VLAN across the different VTEPs over the IP network. We could see that the client in VLAN 10 could reach the clients in VLAN 10 on other VTEPs. However, we were not able to reach the clients from VLAN 10 to VLAN 20 over the other VTEPs, and for that we needed to configure the L3 VNI, which we will now cover in this section. Before we go into that, let me show you one quick thing. In the VTEP 1, if I do a show BGP L2 VPN EVPN, this is the summary of the routes you have. But if you look at the details, and you can see this is route type 2. Route type 2 is what we see when you have the routes within the L2 and L3 VNI. We also have route type 5, which you will see when we have the external route configuration. As of now, if you do a detail of it, show BGP L2 VPN EVPN, and then route type 2, the tag number is going to be 0. Then you need to define the hex string, which is the MAC address here, followed by the IP address 10.21. That is going to show you the details of the route in the BGP. You can see that it is learning it from the VTEP 10.0.02. It was advertised by 10.0.09, which is the route reflector. It has a label of 10010. This is nothing but your L2 VNI, what you configured. It also has a route target of 10.10010. This is how you are importing the routes, because you remember when we configured the L2 VPN instance for VLAN 10, we defined the route target export as 10:10010. So this is something which needs to be matched. Otherwise, you are not going to be importing that route in your BGP. Having said that, now we will move to the L3 VNI configuration. We will see what needs to be done for that. Before we do the lab part of the L3 VNI, let me show you one quick thing in the theory here. Let me do a little cleanup on that. 1 second. All right, this looks better. Here, if you see that you have a client which is in VLAN 12, this is switch number 1, this is VTEP number 1. Let's say this is VTEP number 1, and this is your VTEP number 2. You can see on VTEP 1, I have VLAN 12, I do not have VLAN 13. But on the VTEP number 2, I have VLAN 13, but I do not have VLAN 12. But these are belonging to the same customer, and they want the entire VLAN routing. So I need to somehow route the packet between VLAN 12 and VLAN 13. The one way you could route the packet is if you had both SVI present on the switch VLAN 12 and VLAN 13. You could do it locally. But here, since you do not have it, what you need to do, we will configure one VLAN, a dedicated VLAN for L3 VNI per customer. So if you have one customer who has 10-20 different VLANs, you still need to configure just one single L3 VNI VLAN number. In this case, we have configured VLAN 99. And what the switch will do, it will route the packet from the VLAN 12 over to the L3 VNI VLAN, what you have defined here, which is VLAN 99. It is then going to breach the packet across the network through VLAN 99 with that VNI number. So you will need to map a VNI number to this VLAN, which is going to be L3 VNI mapping. It is going to breach the packet using that L3 VNI number. Okay. Once the destination VTEP receives the packet in that L3 VNI, it knows what the L3 VNI is mapped to. It is going to then route the packet back to the destination VLAN where it is mapped to. It is going to do the lookup, and then it is going to send the packet to the destination finally. So this is how the flow looks like. You are doing routing, then bridging, and then routing. So here you are doing routing, here you are doing bridging, here you are doing routing again. This is how your L3 VNI configuration is going to work. That's the reason it is called integrated routing bridging, IRB. But behind the scene, you are basically doing route, bridge, and route. Now let's take a look at the CLI configuration. If we go here, the first thing I need to create is I need to configure a VLAN number which is dedicated for this particular customer, not dedicated for per VLAN, but per customer. So for customer A, for which we are trying to build the VxLAN EVPN, let me do a VLAN 99, maybe give a name VLAN 910, maybe 901. This is the first customer, and let's start with 9 for any L3VNI. I'm starting with 9. It's any number you can choose. I'm giving a name, let's say L3VNI customer A. I'm going to create interface VLAN 901, give an IP address, let's say 99.9.01. This is my VTEP number 1, so 1 to 55 to 55 to 55 0, doesn't matter. You will need to create a VRF if you want to do it in the if you want to do it for multiple customers. You will definitely want to segment it, right? You do not want to have you do not want to mix your routes for different customers. So if I do a VRF definition and then customer A, you give a RD value. In this case, you have to hardcode it. Like in L2 VPN, what we have done is we did not hardcode the RD value. It was auto-generated. We only define the route targets. But in the L3, you have to hardcode that. I can give a name 10001, which is my IP address, followed by the customer name. This is 901. I'm going to address family. I need to do route target for both import and export. I will do, and again, this has to be same across the whole thing. So it is going to be 901 and 900, let's say 900,001. Okay, this is for my first L3VNI customer. This is the number I'm choosing, 901,900,001. This number, route target, I need to match on all the VTIPs where I want to make sure that my VLAN routing can be possible for this customer. Actually, I need to add one more keyword. We will talk about this later on, stitching, whenever we have time. I do not need this, but I need only this. This should be fine. No auto route target. Okay, this command is not there. So let's see what we have configured now. If I do a show run VRF customer A, we have configured a route distinguisher. Then we have configured the route target value. Now, if we go to config T, interface VLAN 910, which we have configured here, I want to put this particular VLAN in this VRF because this is dedicated for this customer. Like simple routing, what you do. So if you do a VRF forwarding, customer A, you put the IP address, no shut. Similarly, for VLAN 10, I'll go to interface VLAN 10. I'll do VRF forwarding customer A. And I will then put the IP addresses back. Okay. After that, I'll configure VLAN configuration 99. I will map this particular VLAN with the L3VNI number. I'll do member VNI 900,001. And then finally, in the interface NV1, which is my overlay interface, I need to configure member VNI, like similarly what you have done for layer 2, 900,001. In addition to that, you don't define a multicast group, but you define the VRF number, VRF name here, you define it, customer A. Under the BGP, I'm going to configure nothing extra. The BGP configuration for layer 2 EVPN remains same. So if I look at the configuration, what I have done specifically for the layer 3, Okay, I think I did the configuration. Okay, I think I configured two incorrectly. Let me delete one of them. No VLAN 910. My VLAN number is actually 901. So let me reconfigure this. If I do a VLAN configuration 901, member VNI 900,001, it says it is already a member of breach domain 99. Okay, I think I configured this as well. Uh, I'll show you the complete configuration here. If I do a VLAN configuration 901, member VNI 900,001. If you look at show run interface VLAN 901, interface 901, VRF forwarding, customer A, and okay. All right. Now let me do show run section VRF customer A, configuration 901, and in V1 let me put this in a text file so you can see it what I have done. This is the only additional configuration I have put under the interface NV. The rest of the configuration was already there. Before that I have done this. Okay, so we have first created one VRF for the customer A. We have defined the route distinguisher, we have defined the address family, and we have defined the route targets. This route distinguisher is something unique per router. I have configured with a loopback of my IP address and then followed by the VLAN number for this customer L3VNI VLAN number. I have defined the route targets. I'm going to use the same values on all the other VTEPs which need this customer VLAN to communicate, do the inter-VLAN routing. I have then defined this interface VLAN 10, which is the customer VLAN. I have defined this under the VRF customer A. I have reconfigured the IP address because whenever you configure the VLAN, the VRF, your IP address is removed. I have reconfigured the IP address back. Here I have created this layer 3 VNI in the database. I have created the layer 3 logical interface for that. I had to create one IP address here. Interface VLAN 901, IP address 99.9.01.1. Okay, it says all right. This is what I have configured. Then interface VLAN 910 is not needed. This is 901 actually. I did a typo when I typed the VLAN number. Then under the VLAN number configuration 901, I have defined the member VNI, which is 900,001. And then last but not the least, under the NVE1, I have defined the member. So you can see quite a few configuration bits and pieces here and there. This is difficult to remember, but if you understand what I'm talking about, the routing, bridging, and then routing IRB concept. So the moment the traffic comes in, it will basically do the routing from VLAN 10 to the VLAN 901, and then it is going to breach the packet over the VLAN 901. So if you remember in this order, then you will understand why we are doing the configuration at every place. So let me write the configuration here. I want to do the same configuration on route VTIP number 2 and VTIP number 3. Now in VTIP number 2, as you can see, I already have two clients, VLAN 10 and VLAN 20. So I need to create, I need to put some additional configuration there. What I do on VTIP number 2 is the RD value, I'm gonna do it different because this is this has to ideally this needs to be different. Typically you want to. The export input value remains same. Interface VLAN 10, the IP address was different in VTIP 2. If you look at this VTIP 2 configuration, VLAN 10 and VLAN 20. Let me put this configuration here for VLAN 10, for VLAN 20. What I need to do is I will put this command VRF forwarding under the both VLANs, VLAN 10 and VLAN 20. The rest of the configuration looks same. VLAN 901, I need to define this locally. Then of course, under the VLAN configuration, you define the layer 3 VNI number, what you want to give. And then I had to create one logical interface for that VLAN. I had to put it in the VRF, and then I had to give an IP address. And then finally, under the interface NV1, I will configure member VNI 9000001, whatever VNI I have defined here in this VLAN configuration, and followed by the VRF number. Okay, don't do autocorrects for me, please. All right, so that's the configuration I will put on VTIP number 2. If I go to VTIP number 3, you don't have VLAN 10 here, you only have VLAN 20. So I will just copy this part. I'll put here. You do not need VLAN 10, so you don't need that part. The rest of the configuration, actually 901, I can give a different IP address here. I don't think it matters, but better to give a different IP address, 255, 255, 255.0. Here I will give .3. The other configurations, it remains same. The route distinguisher will need to be changed. If I go to VTIP number 3, so that's the configuration summary of L3VNI. Now at this point of time, if this is working, then I will expect this ping to work now. If it doesn't work, we will see what is wrong. Okay, it is not working yet. If I do a show BGP L2 VPN EVPN, show VNI, show NV VNI summary, it says total 2 and they are up. So if I do VNI 9000001 detail, okay, it shows up here. I'm trying to ping show IP INT brief. Let me try to ping from there once. Show run interface VLAN 20. 192.168.20 dot from 21. If I try to reach ping VRF, 192.168.10.11. Okay, not working. If I do a show BGP L2 VPN EVPN, let me see if the route is present. So I can see the route for 10.11. I don't see anything for 10.21. That is the problem likely. If I do a show BGP L2 VPN EVPN, I can see the route for 10.11. I don't see anything for 10.21. So which that means if I try to reach 20 dot let's say 20.2. Okay, at this point of time I should have it populated. Yes, now let me take a look at here as well. Okay, so if I now try to reach from here, what I was trying to reach, yes, so now I have the reachability. So previously my VTEP 1, it didn't know about 20.21, and if it doesn't know, then it cannot flood it because I'm not doing any L3 flooding for L3VNI. I need to know this particular prefix, and if I don't know it, then I cannot flood it. There is a way to work around that, like I need to configure route type 5 for this. So for that, at least it will know the subnet which belongs to the other VTEP. And if it knows that even if I don't have the exact route, but I have the subnet which I know it belongs to certain VTEP, I can bridge the packet to that particular VTEP here, and then it can forward the packet from there. But we will take a look at that in the other section. But in this particular case, where we are not doing anything fancy in the L2 VPN BGP address family, we are just doing a vanilla L3VNI configuration. I need to know the host route. If I don't know it, I'm going to drop the packet. So my host was offline, or it was not sending packet. So that's the reason it was not there. But the moment it started sending some traffic, now I can see that 20.21 is now populated in my table. In this particular, you can see 10.0.0.2 route distinguisher table. And the interesting thing is, if we do a show BGP EVPN L2 VPN EVPN, you do a route type 2 tag 0, you specify this MAC address followed by this address. Now you are now seeing two levels. So previously when you had a look at this, you had only one level, which is 100.020, which you use, which is the VNI number for the L2. Now you have the VNI for the layer 3 as well, which is 900.001. And also you have the route target in addition to that. So that's how you are going to import this route in your table. And then you are able to route the packet. If you look at the same thing here, show BGP L2 VPN EVPN route type 2, and you do a tag 0, then this is your MAC address and this is your IP address. You can see that I have the same label for this address as well, which is VLAN number 10 100010, and the route target is also present, which is 901:9000001. So now that you have it reachable, I should be able to ping. Do we have 31? We don't have 31. So what we can do is I can go to this VTEP 3, show BGP L2 VPN EVPN. It knows about 11.21. It doesn't know about 31. So let me do one thing. If I go to this client here, 20.31, and if I try to reach anything, 10.21, 20.21, or 10.11, I should be able to reach that, and that will be my final verification for this L3VNI. So if I go there, 20.31, which is this interface, which is gigabit 106, VRF, and then this is my VRF name. This is my own address. I can reach. Let me try to reach 21. I can reach. Let me also try to reach 10.21. Okay, 10.21 is not able to reach. How about 10.11? It can reach 10.11. So for 10.21, the reason it is not able to reach because it doesn't know about 10.21 in this route. In fact, if you go here into VTEP 2, even VTEP 2 doesn't know about 10.21 because it has gone silent. So if I initiate some traffic from showrun interface, we had 10.21 in VLAN 10. So if I do ping VRF10, if I try to reach 20.31, I should be able to reach from here. Now, since I'm generating some traffic for that, I think I know about this guy, 20.31. Yeah, I should know about it. Okay, let me 11. I can ping 21. I cannot ping 21 for some reason. Am I seeing the 21 here at least? Okay, 21 is now present. How about here? Okay, it also knows 20.21. Maybe I don't have a route, default route, show IP route VRF and then VRF proxy 20. No, it has a route VRF. It can reach ping VRF then 192. If I do, it knows 10, 11, 10, 21. It doesn't know 10, 21, 20, 21, and 20, 31. So 192, 168, 10.21. I can reach 10.21 at this point of time, which I can. 10.21. I can do 10.31. 10.31 is not present, my bad. I can reach 20.21. I can reach 20.31. So yeah, I have reachability from this one. I can reach 10.21, I can reach 20.21, and I can reach 20.31. So at this point of time, I have complete reachability between these clients from here to here and here to here. From this guy, I'm not able to reach this guy for some reason. I need to troubleshoot that later on. Let me try once more. Show run, show IP and debrief. So 2031 is this guy, which is 106. I can reach 1011. I can reach 1021. 1021 I cannot reach for some reason. I can reach 2031. Yeah, so only this connectivity is not present at this point of time, which is from 2031 to 1021. Even though I can see that it knows about 2021 also behind the route VTEP 2. Similarly on VTEP 2, if I do this, it should know about it. It should know about 20.31. Yeah, so typically it should work unless there is any other issues. We'll figure this out, but you can see in a nutshell the configuration is that's all we needed to do. We had to create one L3 VRF, we had to create one L3 VLAN interface, we had to define that, map that particular VLAN into that VRF. Then we had to bind those VLAN interface into the VRF as well. And then finally, we have mapped those VLAN configuration into the VNI, and then we call the VNI to the overlay interface. That's all we had to do. Thank you for listening. And the next session will be the one which is going to focus on the external network, and then we are going to do some verifications and the summary of all we have discussed in the previous three sessions. Thank you and take care.